Video for 1.2. You can pause the video and get the vocab. I'm going to talk through it a little bit so you can also write it just as I'm talking through it. So a couple of the things that we're going to look at are some notation differences. So distance or length is just how far away are 2 points from one another on a line. And so let's say that this had a value of 2 and this was 5. So I could do 2 minus 5 and get -3. Or I could do 5 minus 2 and get 3. So notice when I'm talking about distance, we're always going to give the positive number. So even if I did 2 minus 5, I would still say they are 3 units away from each other. So that's why they put this in absolute value, to recognize that distance is always going to be positive. And so we can have distances that are the same, right? So if we're talking about a segment, a part of a line that ends, we're going to mark them with these tick marks. And notice I just put 1 tick mark, but if I put 2 tick marks and only 1 here, that tells me they're not congruent. So they have to have the same number of tick marks. So they both have 2, that tells me that they are the same. Here's how I notate that. I would say segment PQ is congruent to segment RS. So if segments are congruent, then their measurements are equal. So notice a slight notation difference here. Here I use the segment symbol and the congruent sign. Here I have no segment symbol and equals. So equal is not the same as congruent. They're super similar, but equal is talking about an actual measurement. And congruent is talking about the shape or the figure. So it's saying the segments are the same. This is saying they have the same measurements. So if they're congruent, then their measurements are equal. That's always going to be true. And that's just the definition of congruent. If they're congruent, then their measurements are equal. Okay, for any segment, if I have a point somewhere between the two ends, so not necessarily in the middle, just somewhere between, the segment addition postulate says we can add the 2 pieces to equal the whole thing. Kind of intuitive. We just have a formal name for it. So in this case, that part AB, whatever that length is, plus BC equals the whole thing. So notice again, when it's an equation, there's no segment symbols over the top. Those are talking about actual measurements. Okay, but I could have a point right in the middle, and we call that point a midpoint. So just based on the name, you can kind of tell what it means. Another way we can talk about midpoints is we can say they're a point that bisects a segment. So I put these congruent markings on either side, because if B is exactly in the middle, from A to B has to be the same as from B to C. So if we know it's a midpoint, we can then conclude that AB has to be congruent to BC. Also, we can have a segment bisector, so I could have something else cutting through the middle of a segment. So this scenario matches this picture. So we have a segment AB, it's bisecting DF, so the thing that's being bisected is being cut into 2 equal parts. So M is that point at which it's going through. So on either side of M, that must be equal. So if it's bisecting DF at M, then DM must be congruent to MF. Okay, so we're going to use some of those in some examples here, you guys. So for every example, we're going to draw a picture and justify the first step. So we're going to say, why are we setting up the equation we are? Okay, so we're going to draw this picture. So S is between R and T. So we've got R, T, S is somewhere between. I purposely don't like to put it in the middle, just so I don't end up saying that either side of S is equal. So this one to me is obvious that RS and ST are not the same. Okay, so it's telling me RS, so from R to S, this little piece right here, is 2x plus 7. ST is 28, and then R to T, so that's the whole thing, is 4x. Find the length of RT. So we're going to set up an equation where we first find x, and then we can put that x value back in to get an actual number for RT. So we can use adding these 2 pieces together to equal the whole thing. That is the segment addition postulate. Adding the 2 parts to equal the whole. Okay, so, and I abbreviated postulate there, you guys feel free to do the same. So in doing that, we've got 2x plus 7 plus 28 has to equal 4x. Okay, so now they just asked me to justify the first step, so I'm gonna go ahead and finish solving here. I'm gonna combine some like terms and subtract 2x from both sides. So we've got 35, did I get that right? Yeah, 35 equals 2x divide by 2. So 17.5 equals x. Now they asked me to find RT, so I'm going to go ahead, I'm going to do that up here. So RT was 4x, so we now know x is 17.5. And we get 70 there. So RT is 70. Okay. Sorry, this is the second example for 1.2. My printer is not working well, so we're just gonna go with my handwritten example here. It's the exact same as what's in your packet. Okay, so here is a example that we're gonna try and prove. So it says segment AD bisects segment CD at B. CD equals 2x squared minus 8x, BD equals x squared minus 15. Prove that CB equals 10. Okay, so let's draw a picture first of what's going on. So AB bisects CD. So CD is the thing being cut in half. So CD is being bisected at B. So that means B is going to be right in the middle. And then AB, it doesn't really matter how AB looks, but AB is the thing cutting CD in half. So because it's being cut in half, remember, this is something we had from the vocab. If it is being cut, being bisected, that means those two pieces are congruent. Okay, so that is something that I kind of knew because of that word bisect. So all of this stuff, like this whole sentence right here, that is where we start, and that's everything that is given to us. So we always want to start a proof with a given statement. So that is what's given to us here. So now we knew, because that word bisect, that CB was congruent to BD. So CB, and here's something you can, just to skip a step. Actually, I'm going to show it here just so you guys can see it. So I'm going to say segment CB is congruent to segment BD. Why I knew that, my reason for saying that, is because of that word bisect. Bisect means it has to cut exactly in half. So I'm going to say definition of segment bisector. That's what's being cut in half is a segment. Okay, now I have an equation. I want to eventually get to CB equals 10. So that means that the very last thing I should write is CB equals 10. So I need to find what x is so that I can plug in a number and hopefully show that CB is 10. So I need to get away from congruent and go to equals. So remember that funky notation that allows me to switch between equals and congruent? So I get rid of the segment symbol and I turn from congruent to equal. That is the definition of congruent segments, and I'm just using the congruent symbol there. So it's saying because they're congruent, their measurements are equal. Okay, so now that they're equal, I'm given some things for, oh, and I'm sorry, you guys, I think I wrote that wrong. This should be CB. There we go. Okay, so because those are equal, now I have an expression for CB. I'm going to substitute 2x squared minus 8x in for CB and x squared minus 15 in for BD. Okay, so that is substitution. When I substitute something in for something else, that is equivalent. Okay, now this is an equation that I want to solve for x. Well, I notice right away I have some x squared, so I'm going to try and set this equal to 0. So I'm actually going to do that in one step. So I'm going to move the x squared over. So I have to subtract x squared and I have to add 15. So I'm actually doing this in the same step. You guys are welcome to do the same thing. I just need to put both properties. So I use the addition and subtraction property of equalities. Okay? Okay, so 2x squared minus x squared is just x squared. I can't really add those because they're not like terms, so I'm going to write them next to each other. Minus 8x plus 15 equals 0. Okay, so here's my standard form of a quadratic, right? I have a 1 in front of x squared. I have it set equal to 0. And that was just me simplifying after using my addition and subtraction property of equalities. So now I want to factor. So I want two numbers that multiply to be 15 that add up to be negative 8. So they must be both negative because they have to multiply to be a positive but add up to be a negative number. So that's going to be negative 3 and negative 5. They multiply to be positive 15, but together they add to be negative 8. So that is factor. Okay, now I can set, now that it's factored, I can set each factor equal to 0. And that, remember, is called the zero product property. Okay, so now if I solve each of these, so for this one I'm adding 3 to both sides, for this one I'm adding 5 to both sides, since it's just addition, it's the addition POE. All right, so we get x equals 3 or x equals 5. Okay, so they want us to show that CB was 10. CB was 10. Okay, so remember CB was this expression. So we had CB equals, now here I have 2 values to plug in, you guys. So I'm actually going to do this simultaneously in the same line because I have to plug in 3 or 5. So I'm going to say CB equals, okay, so I'm plugging this in up above. So I got 2 times 3 squared minus 8 times 3, or CB equals 2 times 5 squared minus 8 times 5. Okay, and so what I'm doing is I'm plugging in those 2 x values. Substitution. Now, a lot of times with these problems, you guys, one of the values is going to give us something negative. And remember, we're talking about a length of a segment. So we cannot get negative answers. So if one of these turns out to be negative, we're not going to include it as a solution. Okay. So here I'm going to simplify each. Okay, so we get CB equals, so 3 squared here is 9. Make sure you follow order of operations. So 9 times 2 is 18 minus 24. So that one would be negative 6. So I'm just going to cross this out. And we're going to say length can't be negative. But I'm showing that I checked both of those. Okay, here, 5 squared is 25. And then minus, 25 times 2. I forgot the times 2 part. All right, so 5 squared is 25 times 2 is 50. Minus 8 times 5 is 40, so CB equals 10. And again, that's just that same reason of simplify, and that's what we were wanting to show, that CB was equal to 10. Okay, that is it for 1.2. Thanks for watching.